Hello everyone, myself Tahira Mazumde. I am from IT department AKGEC Engineering College, and today I'll be talking on the topic function and operator overloading, which comes under the subject object oriented system design with subject code KCS 054. To start with, let me first discuss the topics which we'll be talking about. We'll start with talking about what exactly polymorphism is, what are the types of polymorphism, then what do you mean by function overloading, what do you mean by operator overloading, and what are the rules that needs to be remembered or kept in mind when we are talking about overloading. Okay. To start with, let us first start with the definition of polymorphism. What is polymorphism? The word polymorphism is derived from a Greek word, poly. It is derived from a Greek word poly. And what does it mean? Poly means many. It means many. And morphos means forms. So polymorphism in Greek means many forms. So we basically can define polymorphism as the ability to use the same name for two or more related but technically different tasks. So polymorphism is used for having the ability to use the same name for tasks which are technically different but may be related. For example, when you're talking about woman, a woman can play different roles like that of a daughter, that of a sister, that of a wife, mother, and so on. So it's this, the playing is the same name is what the woman is playing the role. That is the same name, playing, and the tasks are different, that of a daughter, that of a sister, that of a wife, that of a mother, and so on. So that is what polymorphism is all about, same name but multiple different tasks which are somewhat related. Okay, now we move on to the next topic. The next topic is what are the types of polymorphism. Polymorphism can be briefly categorized into two types: compile time polymorphism and runtime polymorphism. From the name itself, we can understand in this case, this is the one which occurs during compilation, and this is the one that occurs during execution time. Under compile time, we have two kinds of polymorphism. One is function overloading and the other one is operator overloading. And under runtime polymorphism, we have virtual functions. In today's class, we'll be basically talking about function overloading and operator overloading, which comes under compile time polymorphism. So we'll start first with function overloading and then we'll talk about operator overloading. What is function overloading? We'll take some example to understand the meaning of function overloading, and then we'll move on to operator overloading. Okay, now we have already talked about polymorphism. We have defined what polymorphism is. Now, before we proceed more into this, let us start with overloading. Polymorphism is basically overloading. It is the same name but multiple forms or multiple tasks. So we are overloading the same name with different tasks. So we'll talk about function overloading to start with, and then we'll talk about operator overloading. Now, what is function overloading? Function overloading, it allows a function that conceptually performs the same task on objects of different types to be given the same name. That means what we do in function overloading, we will be having functions which will be having the same name, performing similar kind of task, but the difference is, in case of function overloading, we will be having multiple functions which will be having same name and performing similar kind of task, but the difference will be on the objects on which those functions will be performing the task. This point will be more clear and when we take up some more examples on function overloading. Now, let us start with operator overloading. What is operator overloading? Operator overloading, basically, through operator overloading, we manipulate the operators which are already there or which are built-in operators. We manipulate so that those operators which are already pre-existing, they can also be applied on data objects or user-defined objects which are being defined by the users. And that in that case also, so we are basically overloading an existing operator. Let us say plus. We know plus is an addition operator which works on numeric values, maybe 2 plus 2. 2 plus 2 is 4. So this is this meaning of plus is already defined. That works on numeric values. It might be integers, it might be float. But let us say we have a string ABC and we have a string XYZ, and we want to make plus work in such a way that we concatenate them. X, Y, Z. This is something which is new, which was not existing. This is something which is already there for built-in data type. This is ABC and ABC. These are for string data type, which is different. So this is something which is new. That means we are adding some more functionality to the plus operator. Plus operator is meant for adding numeric value, but we are adding some more extra to the meaning of plus operator. We are concatenating two strings and adding up with a resultant concatenated string. This is the concept of operator overloading. We'll be talking more on operator overloading later on. To start with, now let us come to function overloading. In case of function overloading, we'll be basically having the same name, the same function name. Let us say we are having the same function name. Let us say we are having the same function name. Let us say add. But the function might be working on different arguments. It might be working on integer arguments, or it might be working on floating point arguments and so on. But the same function name, the objects on which these functions are working will be different. So we are overloading the function name, and hence the concept of function overloading. So let us start more into function overloading. So to define function overloading, we can say it is the process of using the same function name for two or more functions, the same name. Fine. What is requirement to achieve function overloading? What is required? For example, I'll just give the function prototype now. Let us say we have a function, add function, as I told in the previous example. And let us say in this add function, we have a scenario where we can pass two integer arguments. Fine. Now we have another function named add. Maybe the return type is different. In the previous example, the return type is void, means there is no return type. Here the return type is integer, and for that particular scenario, we are presuming a case where we are passing three arguments of type floating point type. So here if you see, we have the same function name. But the arguments or the very objects on which these functions are working, they are different. And this is the very concept of function overloading, where we can say like this, that we are overloading a function to do more than one task. The first one will be to do the task of addition on integer numbers. The second one will be to do the task of addition on floating point numbers. Fine. Now, what exactly does, how exactly the compiler decides which function will be called? Now, that depends on our runtime. Let us say inside our void main, let us say this is our void main. We have, let us say, we have declared some variables and so on. Let us say we are calling add function. Now, which add function will be called? The first add function or the second add function? By the way, I just gave the prototype here. The definition I have not given. It is implied it will be given somewhere else, but that is not a concern. Our concern is on the function name. Concept of having two functions having the same name. So let us say we are having the function add inside the mains function, and this function add is called. Now, which of these two will be called will be decided by the argument list. Let us say we are passing two integers, 2 and 5. So this parameter matches with the first case. So in this case, the first function will be called, not the second one. But in case of, instead of having two integral values, if we are having three integral values, in that case, the second function will be called. So the decision is of deciding, rather the point of deciding which function will be called will be decided at runtime on the basis of the values that you are passing to the function, on the basis of the arguments that you are passing to those functions. Okay. Now, so what is the requirement? It requires that each redefinition of a function, that means the prototype or the definition of a function, we need to have different function signatures. What do you mean by signatures? Signatures means, for example, we have a function name, let us say multiply. This is your function name multiply, and we have inside the function we have two arguments, integer, float and long int, for example. Now, by signature we are talking about the values which are inside the parenthesis. That means what are the types of parameters? Here we have three types: integer, float, and long int. We have sequence of what is a sequence of parameters. The first sequence is in what order the parameters are being organized. So first it is integer, then float, and then long int. And finally, what is the number of parameters? This parameters is same as arguments, by the way. So here the number is 3. So we have one more function, let us say multiply. So we are having the same function name. Same function name means it is a case of overloading the function with more than one task. But here, let us say the arguments are just 2 arguments float. That means this 2, I'm just giving the prototype, not the definition, just to understand the concept. So if you look at this, both of this have the same function name. So we are having the same name, 2 functions having more than one, 2 functions having the same name. So function overloading. What is the requirement? The requirement is that their signatures should be different. And what do you mean by signatures? By signatures, we are meaning what is there in that part that is within the parenthesis, or rather the arguments part or the parameter part. They need to have 2 functions with the same name, need to have different types of parameters or different sequences of parameters, like maybe int, here it is having 2 integers, or here it is having 3 integers. Maybe that, or maybe the number of parameters are different. So the 2 functions need to have the same name but different signature. This is a signature part, that which is passed within the parenthesis. So this is the requirement for us to ensure that we can go ahead with function overloading, provided provided the functions which are overloaded, if they have different function signature. Why do we go for this very concept of function overloading? It is only for easy programming, basically, or rather user-friendly programming. In that case, the programmer doesn't have to remember too many multiple function names, which are doing somewhat similar tasks. First one was doing addition of integral values. The second one was doing addition of floating point numbers. So why to give 2 function names? We'll just give one function name and then it becomes easy for the programmer to remember, and which AND will be called at runtime will be decided on the basis of the signature. What do you mean by signature? It means those which are within the parenthesis or within the argument list. Okay, they need to have different types of parameters, sequence, and the number of parameters. So this is an example of function overloading. Let us take an example of function overloading. So we can say 2 or more functions. The very concept of function overloading, they are having same name but different arguments or different parameters. So if you look at this example, we have the function name max here and this function name max here. So we have same function name. So same function name means multiple functions with the same name but doing different tasks. So we are basically overloading the function and we call it as function overloading. In the first case, if you see the signature is they are having 2, we are passing 2 integer parameters, one after another. Here we are passing 2 floating point parameters. So the signatures are different. Now when we are talking about signatures, we mean the values which we are passing in within the parenthesis, or we can say the values which we are passing as arguments. We don't refer to the return type. That does not come under the category of signature, function signature. Now let us look in this example. So both of this, if you just see, they work somewhat similarly, but only difference is the data type. This is just an example, not necessarily they need to be same. We can have another example where the function body might be different. Here, in this case, the body of the function is exactly similar. Just an instance, we might have a scenario where they might be different. And what does this function do? It basically checks the bigger of the 2. Like if A is bigger than B, bigger than or equal to B, it returns A or else it returns B. That means this function returns a bigger number out of the 2 number. But the difference is in the case of the first one, it is working on integral values, and in the case of the second one, it is working on floating point values. Okay, now next is how exactly the whole thing is handled. The function call resolution, it is done by the compiler during the compilation time. And which function will be called, it is decided by the function signature, as I just told in the previous slide. What do you mean by function signature? It consists of the parameter types, the number of parameters, the sequence, and the order in which it is being organized. As I told, the function return type is not a part of the function signature. So this thing goes into deciding how exactly which of the function out of multiple functions having the same name, which of the functions will be called depends on this particular concept. This is just an example of function overloading. If you look at this example, we have 3 functions, sum, with the same name. All the 3 functions have got the same name, but the difference is in the arguments. In the first case, we are passing 2 integer arguments. In the second case, we are passing 2 arguments of type double, and in the third case, we are passing 2 arguments of type character. So we have 3 functions having the same name, but if you look at this part, if you look at the function signature, which is within the parenthesis, if you look at it, they are having the same name, but the signature is different. So right now what we are doing, we are taking up 3 functions with same name and signature. Then next we are going to a program main, where we are taking 2 variables a, b of type integer. We have variables and we are assigning them to 10 and 20. 2 variables c and d of type double, and we are assigning them to some constant values. E and f of type character, and we are assigning them to character a and b. By the way, when you are assigning a to e, the ASCII equivalent of a gets assigned. Similarly, for f also, in f, the ASCII equivalent of b, which is a numeric number, that will be assigned. So basically, e and f will be having numeric value, which is equivalent to the ASCII equivalent of character a and character b. Now, to start with, if we look at this example now, now here in the first case, we are calling the sum function with argument a and b. What is the data type of a and b? It is integer. That means which function will be called? The first function which has got integer argument, that will be called. If you go to the if you go and see the second one, in case of second one, which one will be called? C and D are type what? Double. So double means which function will be called? The second function will be called, which is having double arguments. Similarly, E and F, if you look at the data type, it is character data type. So which function will be called? The function which is having character as arguments, character data type as arguments. Though we are having the same function name, the resolution or the decision of which one will be called will be handled at the compilation time on the basis of the data type of the arguments that are passed when the function is called. And let us come to the body or the function definition. If you're coming to the function definition of sum. So in sum function, we are passing 2 integer arguments x and y. This is the definition of sum. If you look at it, it is printing the value sum of integers, and it is returning the summation of x and y. This is the definition of the second function, taking 2 double variables x and y, printing a message sum of 2 floating variable numbers r, and giving the value of x plus y. Similarly, this third one's definition is coming somewhere here, giving the summation of x plus y, where x and y are character data, and in addition to that, we are passing a string. The message will be coming, some of the characters are this. So this is the program where basically we are dealing with function overloading, having same functions but multiple or rather different arguments or different parameters, or we can say different function signatures, and based on the kind of parameters that we are passing, that will be the decision of which function will be called will be decided. So if you look at this, okay, now if you look at it, when this is the function prototype, where the functions are being declared, prototype. These are the function definitions, and this is your main program. So once the main program is called, these are the first is sum of a and b will be called. A and b are integers. So the first output will be sum of a and b are integers. So this the sum with integral arguments will be called, and this will be the message that will be displayed, sum of integer. It is x plus y. Here x and y are 10 and 20. So 10 plus 20 is 30. So this will be printed. Similarly, sum of let us say the next one is sum of c and d. Now, sum of C and D, what the compiler will do, it will compare it matches with which one. It will see what is C and D. C and D is double. So, next it will compare it is which one, having two double arguments. Then it will come to the definition of double arguments. Here it comes, and then it runs this codes. And the output will be sum of two floating point numbers R. It will find the summation of X and Y. Here X and Y is C and D. C is 7.52, D is 8.14. It will print the summation of this two, and the summation of these two is 15.66. So, this is how the things proceed, and the same thing will be done for sum of E and F. E and F will be matched. Here it matches E and F. When you are talking about E and F is which one variables? Character. So, it will go to that particular function prototype which has got character data type. It will come to the case where the variables are character. It will come to the taking the definition from that function where the variables are character data type, and this will be printed on screen. That is, sum of characters are X plus Y will be summed up. What is X and Y? X and Y and E and F. And what is E and F? A and B. And A and B's ASCII equivalent values will be taken up, and the summation will be done. So, this is a typical example where function overloading is being used. Now, let us come to the next one. The next topic is operator overloading. What is operator overloading? Operator overloading means assigning additional operation or job to an already existing operator, an operator which is already existing, and we need to define some more roles to that operator. That is what operator overloading is. In C++, most of the operators we can overload. There are some exceptions. We'll be talking about that later on. That is, one example is our ternary operators. Ternary operators cannot be overloaded. Other than that, almost we can very well overload binary operators and unary operators. So, just an example, let us say addition. I have already given an example in the previous slides. Like, we know that plus is meant for addition of numeric value, but we can also work in such a way that plus can ultimately be used to concatenate two strings. This definition is not existing. We are defining our plus, or rather we can say we are adding some more functionalities to plus so that it has the capability of adding two strings and getting a concatenated value. And we need to remember one point: when an operator is overloaded, we also need to remember that the original meaning of that operator should not be lost. Like, we are talking about overloading plus operator, but we should not end up doing subtraction or some other task. We need to be aligned with the meaning of the original operator. So, once we have done the overloading, we can normally proceed with the programming in such a way as we are using those operators for built-in data type. So, let us take an example, and this thing will be more clear. Now, let us take the example as I told you. Why do we go for operator overloading? See, if you are seeing this similar example I already took, we have, let us say, numeric variables, integral values n1 and n2. We know this plus is meant for summing up n1 and n2, we know very well. But for example, we have got two strings and we want to do addition. This is something which is not there, but we can further go for going for operator overloading and having some enhanced functionality, so that we can add up values which are already not predefined, and that can only be done through, again, operator overloading. Now, operator overloading, when it comes to operator overloading, we know that operators are of three types: unary, binary and ternary. Unary works on one operand, binary on two operands, and ternary on three operands. When it comes to operating over the operator, we can overload unary and binary, but we cannot overload ternary operators. This is one point which we need to remember as we proceed with the operator overloading. And one more thing that we need to remember is that we can only overload operators which are already existing. Like, we know plus is an operator, we know minus is an operator, we know modulus is an operator. So, those mathematical operators which are already existing, we can overload. This is, we cannot make a new operator, let us say dollar, and try to give some functionality to that. This is something which is not possible. Only existing operators can be overloaded. We can't create our own operators. That is a point that needs to be remembered. Now, let us talk about, now when you're talking about operator overloading, we'll be having a special function called operator function. We'll be using a special function called operator function. And what is this? This will be a special function that we use for the purpose of overloading of operators. And this operator function, basically, what does it do? It defines the operations which the overloaded operator will be performing. We'll be taking an example to understand this more. And we basically do the operator overloading by writing an operator function. only through operator function we can do operator overloading. And for writing an operator function, we all know what a function is. A function is something, it is a block of code which has a function name, return type, it has got arguments, function body, and so on. We all know what a function is. So when it comes to operator overloading, we also need a function. Only difference is that we need an operator function. And for writing an operator function, we have to write a function name with the keyword operator. We can't just choose a function name. The function name should have the keyword operator. This is the mandatory requirement when it comes to doing the concept of operator overloading. So operator for loading, for operator functions, we can, if you want to overload operator, if you want to overload operators, we can do that. We can go for using operator function, and operator functions can be implemented either through making them as member functions of a class or as non-member functions. That means this operator functions can be written as member functions of a class or as non-member functions. That means they don't belong to any class. In that case, mostly these functions are friend functions. And the way the operator functions are written, it differs from the member and non-member functions. We'll take up an example. This is the syntax. This is the syntax of an operator function. Like we have the class name, that means onto which particular class the member operator function is a member. This is the first one. As I told you, operator functions can either be inside a class, that means it can be a member function, or it cannot belong to any class. So this is a case where the operator function is a member function of a class. So in that case, you have to write to which class the operator function belongs, the return type of the operator function, the arguments, and the body. Now this is a case where if you write the function definition of the operator outside the class, we all know we use the scope resolution operator when the function definition is written outside the class. But if you're writing the same definition inside the class, you don't have to write the scope resolution operator or the class name. So here we are, often we have operator functions. Normally they return an objects. So the returning data type, the data type of the return type, that will depend upon your requirement of the program. They can be any data type, or they can be objects of the class of that particular class name, or they can belong to any built-in data type. We'll take an example to understand that. Now, if you look at the syntax of this argument here, this hash, basically we have to write the return type, class name, followed by scope resolution operator, then the operator. This is a keyword. This is the keyword which you have to always write when you're going for overloading an operator, followed by hash. What is hash? Hash is the operator that you will be overloading. It can take values like plus, minus, multiplication, whichever operator you want to overload. You have to write that particular operator instead of writing the hash symbol here, and the arguments that are involved for that particular overloaded function. So we'll take an example more to understand this. This is just a brief syntax, and the format of this function, the number of arguments required will change based on the kind of operator that we are trying to overload. When you're talking about kind of operator, we are talking about whether the operators are unary operators or binary operators, or whether we are talking about unary or binary. Now, when you're talking about unary operator, so in case of unary operator, we need to remember you have the same syntax as discussed previously, but the difference is that we won't be using any argument. That is the case when the operator function is a member function. But if we're going for friend function, the scenario will be different. We'll take it up by now, if possible with time. So when you're talking about unary operator, the argument list will be empty. Now, when you're talking about binary operators, we want to overload binary operators. In that case, again, through operator functions which are member functions of a class, in that case, the syntax still remains the same. Hash indicates the operator that we want to overload. But here, if you're talking about binary operators, here we need to have one argument. If you want to talk about overloading binary operators, here we will be passing one argument. If it is unary operator, as discussed here, if it is unary operators, we won't be having any argument. We'll take an example to understand this more. Now, this is an example where trying to overload using unary operator. let us take an example. See, if you look at this example, this is standard things which you need to do for all C++ programming, or for this is an example, this is a code written in C++ as such. So we are having a class unary op with class members X, Y, and Z, and inside in the public section we are having constructor. Why constructor? Because they're having the same function name. So through a constructor unary op, what we are doing, we initializing the member variables to 0, and we have another constructor unary op where we are passing 3 integral arguments, and these integral arguments are used to initialize the member variables of X and Y to A, B, and C. So we are in this particular example, we are having 2 constructor functions. We are having a display function. What does this display function do? It prints the value of X, Y, and Z. So this is the beginning part. Now what we'll do, we will try to overload a unary operator minus, that is meaning negation. So let us do so. The syntax, if you look at it. Okay, now let us come to the syntax of that. We are writing the function keyword operator, which is a member of class unary op. What is unary op? If you see, it is the class name. So, and the return type is void, it is not returning anything, and the operator that we want to overload is negation operator, and we are not passing any arguments. Fine. So what does this function do? What it does is that the members variables were X, L, Y, and Z. What it does, it negates those X, Y, and Z and reinitialize X and Y and Z to the value of minus X, minus Y, minus Z. Fine. Now, so this particular function, basically, if you see, it negates the existing 3 member data X, Y, and Z. So if you look at the main function, we are creating an object un with in that object we are passing 3 values, 10, minus 40, and 70. So basically constructors will be used. Which constructor? We are passing 3 arguments, 10, minus 40, and 70. So out of the first and the second constructor, the first constructor will be called, if you are not passing argument, in that case the member variables or the member data will be initialized to 0. But since we are passing arguments 10, minus 40, and 70, so the second constructor will be called, and here the member variables X, Y, and Z will be initialized by the values that we are passing. The values that we are passing is 10, minus 40, and 70. So X, Y, and Z, or rather we can say, we will be creating an object un with values A. What are the member variables? X, Y, and Z. So with values X, Y, and Z, X will be 10, Y will be minus 40, and Z will be 70. So what does this do? Then what we are doing, we are calling the through cout function, we are printing a message, numbers are. So in the output, numbers are message will be coming. In the output screen, what will come? The numbers are will be coming. This will be played, and then since it is /n and new line, cursor will go to the next line, and then display function will be called. What is display function? Cout the values, the variables, the values of X, Y, and Z. What is the values of X, Y, and Z? It will be 10, minus 40, and 70. So this is what will be coming in the output part. So after that, we are calling negation operation, minus of un. We don't have any operator. Plus, we know that negation operator works on only numeric values. But here, if you just see, we are negating un. And what is un? Un is not a numeric value, or rather un is an object of class unary op. So we are negating un. And how is it possible? It is only possible because of this function, operator overloading function, where we have given the meaning of negation. And what is the meaning of negation? Negation, it basically negates the value of X, Y, and Z. So when you're passing minus u, when you're doing minus un, so the original members of X, Y, and Z will be negated, and instead of 10, X will become minus 10, instead of minus 40, Y will become 40, and instead of 70, Z will become minus 70. And then now again, when you are calling the display function, so what will come on the screen? Numbers are after the overloaded. This will be after this, it will be coming whatever values we had. It is minus 10, 40, and minus 70. So in the output screen, we will have minus 10, 40, and minus 70. So this is a typical example of a case where we are overloading negation operator, or rather we can say unary operator, by using member functions. This is overloading binary operators. So in case of binary operators, if you look at this example, we have got complex function which has got two member variables, member data, real and imaginary. We have got a public section where we are having three constructor functions, complex. The first one is without any arguments. The second one is passing to, this one is not, this is not constructor function. The first two are constructor function. So the second one is constructor function where we are passing two double arguments, and the third one is an operator function where we are passing one argument of which is an object of type complex. The operator that we want to overload is plus, and this function basically returns an object of type complex. So what is to be noted here is that we are having two constructors, complex with no arguments, complex with two arguments. Why these two are constructors? Because both these functions have got the same class name. Then we are having an operator function, meaning we are trying to overload, we are doing operator overloading. Which operator overloading we are doing? We are doing the overloading of plus operator, and we are passing an object of type complex. Fine. Now, if you look at this example, complex basically in this case, the first complex, this one is basically the definition of the constructor. What does it do? It is passing arguments R and I. R and I are being used to initialize image and imaginary and the real part. So this is a constructor function which is used to initialize the real and the imaginary data member of this class. And now we are coming to the operator function where we are trying to overload the operator plus, and we are talking about a particular class complex which is having the operator function. So that particular class, its own member data is real and imaginary, and to that class we are passing an object of type complex, and the name of that object we are presuming it is param. The name of the object is param. So what we are doing, we are creating a temporary object temp, and in that temporary object's real part, what you are doing, the real part of that particular class we are taking, and into that we are adding the real part of the object which is being passed to that particular class, and both the reals add up, and the new value that we have been getting, it is then added to the real part of the temporary object temp that we are creating. Similarly, the same thing happens with the imaginary part. The same thing happens with the imaginary part. We are taking the imaginary part of that particular class on which this operator is a member function. We are taking the imaginary part of the object to which this function is being, the operator function, the object which is being passed to the operator function, its imaginary part we are taking. We are adding both these parts, and the value that we are getting, we are assigning it to the imaginary part of the temp. So ultimately, what this particular operating function is doing, it is creating a new temporary object, updating its real and imaginary part. Temporary object of what type? Of type complex, and after updation, it is returning that particular object. So ultimately, this is how it works. The example. So this is what we have done. This is the replica of this one. So later on, what we do, if you write a code like C1, we are creating an object C1, we are creating an object C2. C1's, this is the real part, this is the imaginary part. Both of this are being created how? By using the constructor function, the second constructor. Once both the objects are created, we are creating a new object C3. We are doing the summation of C1 and C2, and where C1 is not a numeric value, or rather it is an object of type complex, C2 is an object of type complex, and this is only possible because of this particular definition of operator overloading. So ultimately, we will have something like this. If you look at it, well, this is C1, this is C2. C1 we are calling the print function. So if you remember the print function, we have the print function here. Okay, the print function, we somehow have missed it out here. So C1's print function basically prints the imaginary part and the real part, the real and the imaginary part, along with indexing a variable I, value constant I. Similarly, C2, the real and imaginary part is printed, and then what we are doing, we are creating an object C3 where C1 and C2 is being added up, and finally that particular value is stored in C3, and so we are printing C3. So when you are going for C3 printing, C3's object, the real parts, if you just see, they are added up, the imaginary part they are added up, and this is the final output that is coming in the screen. थोड़ा मतलब लेट हो गया तो मैं ना कुछ स्लाइड ये स्लाइड स्किप कर रही हूँ, मैं यहाँ सीधा आ जाती हूँ। तो अभी मैंने स्किप किया, ये नहीं रहेगा, अभी मैं यहाँ से शुरू करती हूँ। तो अभी मैं स्टार्ट करूँ। Okay, now let us just talk about the rules which we need to remember when we are talking about overloading the operators. So we can overload virtually any operators of C++, but we need to remember that we cannot create our own set of operators. Next is we cannot change the precedence of the operators. Neither can we change the very meaning of the operator. Like we cannot use a plus operator, but on the process we are doing a subtraction task. We cannot also alter the predefined job that is performed by the operator. And we can overload almost all unary and binary operators, but we cannot overload ternary operators. And for doing so, we can go for member function approach, or we can go for friend function approach. In today's example, we have used the examples of member function. If you're going for friend function, things will be a little different. What is the difference? The difference is the operator function will not be a member of the class, it will be outside the class. So in friend function, I'll just summarize. If we are going for unary operator, in that case, unlike zero argument for member function, here we need to be passing one argument if you're going for friend function. And if we're going for binary operator overloading, unlike one argument in case of member function, for friend function we'll be passing two arguments. So this is another topic which can be discussed later on. Today we have discussed about member function approach. At least one more point that needs to be remembered is that when you are overloading binary operators, at least one of the operators, at least one of the operands should be user defined. So we can overload operators only for some classes. We can't overload an operator for built-in data types. That is point which we need to remember. And the operator function we need to ensure that the operator function returns an object of that particular class on which it is working. And these are the references or the books which has been prescribed as per the syllabus prescribed in AKGEC, and I have also referred to this particular books for understanding the concepts more in detail. And that much for now for this topic. Next time we'll move on to some other topics. Thank you.